All right. I have to check the light off. So dark today, hey? Crazy. Okay. How do we know if something is odd? Put your hand up if it's an odd number. Put your hand not up. Did I press record? Yep. If it's an even number. Hand up, odd. Hand not up, even. Got it? 29. Thank you. I like how you reassured yourself for looking at others. 28. 27. 26. 25. 24. 23. 21. 8,764,543,201. What are you guys listening to? The last number, the last digit. That's all that matters, right? We don't care about the other digits. All we care about is that last digit. So here it says, Eric has been assigned the task of determining how many odd 4-digit numbers there are. So odd, when you see that, that indirectly tells us that it ends in an odd digit. Right? Your last digit is odd, that's all. Like when I did 29, 28, 27, 26, I was keeping the two the same. That didn't change anything for odds and evens. Now a 4-digit number. A 4-digit number is one that literally could fill in 4 blanks. We agree? But I'm going to tell you right now, I'm going to pay you in a 4-digit number. Okay? So I'm going to pay you that much. Wait, I'm going to pay you this much. Now I'm going to pay you in a different 4-digit number. Perfect. You all happy? It's a good 4-digit number. We're happy. Are those 4-digit numbers? Are they? No, those aren't 4-digit numbers because they have digits in front, right? And in elementary school, your teacher would say to you, if you have a 0 in front, you can just erase it, right? That's what they told you the whole time. So we can do that. So if I erase these and try to erase that one, but it's going to erase everything else. I actually had a 1-digit number and a 2 and a 3, didn't I? Right? So in order for something to be a 4-digit number, it has to have 4 digits. That's true. But what is the restriction? The first digit, what? Can't be 0. Exactly. So if it says 4-digit number, that's indirectly telling you the first digit can't be 0. Now some people fall to this if I say 4-digit code. Can a 4-digit code start with a 0? Absolutely. Because a code could be 0000, couldn't it? So we're going to go and make ourselves a 4-digit odd number. We must deal with restrictions first. So if we deal with the back digit, it has to be odd, right? So it could be 1, 3, 5, 7, or 9. So we list the options below, what they could be, right? How many of those are there? 5. So I put the amount of them above, like we did earlier on Monday or on Tuesday. It depends on when you were here. Then we know that the first digit can be anything but 0, right? And in each of these blanks, I can only fit a 1-digit number, right? That's why I couldn't put like 11 in that back one, right? Because that would be 2 1s. So in this front one, I can't have a 0, but I can have the digits 1 to 9, which is 9. Then I deal with the middle 2 next, because they didn't have any restrictions at all, did they? So what could they be? 0 to 9. Which is 10 and 10. And what do I have to do with all of these? What operation? Multiply. Remember the dots? And the reason why you have to remember the dots is if you don't remember the dots, then this is actually 910,105, right? If you don't have the dots, it's a number, which is not at all what it is. So you have 4,500 different odd numbers, right? 4-digit odd numbers. B changes it up a little. Eric has now been assigned the task of determining how many odd 4-digit numbers there are with no repeating digits. So when you see no repeating digits, you need to think box and hold. We're going to box and hold a number. Because in order to guarantee not having a repeating digit, we have to box it and then never use it again. So we're going to do it the exact same way, but we can't have any repeating digits. So we can't have the number like 4011. Okay? The easiest way to get rid of those is to just pretend you're holding digits along the way. So I'm going to go 1, 3, 5, 7, 9. Now I'm going to pretend to hold one of them there. Either the 1, the 3, the 5, the 7, or the 9. Due to me being lazy, I hold the 9, so that when I write this one next here, I can write 1 to 8. If I held like the 3, I'd have to write 1, 2, and then 4 to 9, right? But you could pick any of these to box and hold. So I'm going to box and hold the 9, but I still had 5 options, right? The reason why I'm holding that number there is so that when I go to list my options in the first blank, I don't list that 9, right? Or any of the 5 that you picked. So here, I can't have 0 and I can't have 9 because I pretended I had kept it there. So I have 1 to 8, which is 8 options. Then I have to remember to box and hold something, right? So I'm going to box and hold the 8. So then I have 1 to 7, which everyone says is 7 options. 1 to 7 is 7 options. That's true. But you would be wrong if you put 7. Sorry? What did we not put in the first and last blank? What have we not used up? Because you couldn't use it. 0. We have to remember to bring it back because it is actually an option for that blank, isn't it? Right? If you're someone who's like, yeah, I'm totally going to forget that, then what I would do is I would circle it and leave myself a little note that says, when non-repeating an odd, bring back 0. Okay? Do you think you'll have the answer that if you put a 7 there, do you think that answer will be there on your unit test? Yeah, it's common error. If you forget to bring the 0 back when you go 7, 6, that answer will totally be there. So they'll have all the common errors. So that's why we need to know our stuff 100%, not 90%. Because when we go to the test, they have all the 3 common errors on your test too, right? So if we know our stuff, we won't make those errors and it'll be all good. So we have an 8 here. I'll hold the 0, 1 to 7, and I have a 7. And I believe that's 2,240. You're going to try example 6. The catch here, when it says 2 letters are not repeated, just keep this in mind, that it just means the last 2 letters are not repeated. It's not dependent on the first letter. Okay, so the last 2 letters are not repeated. So try that question out. So this one says, car number plates in an African country consist of a letter other than I or O, followed by, so we have a letter other than I or O, followed by 3 digits. The first cannot be 0, followed by any 2 letters that can't be repeated. So, what we need to do is we need to make sure we deal with the restrictions first, okay? It doesn't matter which order, but we have to deal with them first. So this is two letters that can't exist, but there's 26 in the alphabet, so that'd be 24. This one can't be 0, but it can be 1 to 9, so that's 10. And then I go to the back, 2 letters that can't repeat. So this one could be A to Z, which is 26, and let's say I box the Z, then this would be A to Y, which would be 25. And then the middle, is there any restrictions on those two? No, so those can be 0 to 9. Yeah? What do you mean? That's totally a 9. Always has been a 9. Never was a 10. Totally a 9. These are 10s. What are you thinking? You're just seeing it. So it's just because you're so far away. You know, totally. Or it may have been a 10. I don't know. Options. Thank you for saving my bacon. Everyone would have been quiet and known it was a 9 and wrote 9 and just let me fail miserably at it. Okay. Gotta make sure we put our multiplication dots. And then what is that? It's like 14. What is it? Might not be. Anyone? Ruler. Someone read the number. Is it scaring people? Or you just don't know? Yeah. 14,040,000. Like that. You guys are all giving this look like it's summer. I don't know how to say big numbers. You're right. You did perfect. Good job. So that's a lot of options, right? In our license plates, if we didn't have restrictions at all, we have 26 times 26 times 26 times 10 times 10 times 10, right? So we would have letter, 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 number, number, number. So we'd have 26, 26, 26, 10, 10, 10. I think it's like 15,000, 17,000. Happens to be on this calculator. So that's what the license plates were, or are, right? But we can, they said we were going to run out of license plates. Now, keep in mind that that's the maximum number of license plates there could be, right, with our old way. But they have restrictions on some of the things. I just didn't say what the restrictions were. Okay, so this is maximum if there were no restrictions. So they said we're running out of cases, right? We won't be able to make license plates anymore. It's getting scary, is what they were thinking. So they added another number, didn't they? So adding another number, people don't think it's like a big deal. They're like, well, if they just add another number, what does that do? Another number adds a 0 to this, right? So we go from 17 million to actually 175 million, which is huge, right? Adding just another 0 makes it move a whole decimal, like it makes it move a whole place value. If they would have added 26, another letter, they would have even made more. But they're thinking 175 million, probably we're not reaching that, so we're probably okay. So, that's where you have that. Make sense? So you do use pros and cons in life, you just don't really think about it. So we're going to look at example 7. James wants to travel from Pitland to St. Luke's. How many different routes are there from Pitland to St. Luke's? If you pass through Q or R. So we can use fundamental counting principle because we can say how many paths from P to Q? How many different options? 2. And how many different options from Q to S? 3. So we actually have 6, right? Then if we go the bottom route, where we go through R, which could be Rutherford, P to R is how many steps? Or how many options? 3. And we only have 1 going from R to S, right? It's like the highway going to Fort McMurray. You got 1 option. That's it. So you're going to take it. 3 times 1 is 3. Now our biggest decision is when we add, do we add 6 plus 3 or do we multiply 6 times 3? Add or multiply. So let's think about it. We have this many paths I could do, or I could do these paths, right? And we do what? Multiply, right? That's what we went over. Or we will add. Now some people think and add. Look at how pretty they look together. Like you think and should go with add. They're basically best friends. But because they're so similar, they hate each other. They absolutely do not go together. This is like, we're too similar. We just, no thank you. It's like my brother and I, we fight sometimes because we're basically the same human. and we both deny that fact. So, and add do not go together. So, and is just multiply, and we're going to say we're going to take these paths or these paths, right? We're not going to say that we're going to take those paths and those paths. That's craziness. Like, you're literally driving back home and redoing it. Like, that's just crazy. So because it's or, we're going to add, and we're going to get 9 roots. 9 different roots. Okay, you guys are going to try example 8. Okay, let's go through this one. The telephone numbers allocated to subscribers in a rural area consist of one of the following. The digits 345. So you could either go 345 and go 111, or you could have went the digits 345, which is 1. Either way, it would still get you 1, right? If you don't have options, you have to pick 3, then 4, then 5. Followed by any 3 further digits. So these can be 0 to 9, right? So 10, 10, 10. So we get 1,000. Then we have the word or. What do we do with the word or? Add. The digit 2, followed by one of the digits 1 to 5, followed by any 3 further digits. So we have to deal with these ones first, right? Because they're restricted. So we go 1, 5, 10, 10, 10. So we add 5,000, and we get 6,000. Okay? You guys try example 9, bullet 1, and then try example 9, bullet 2, but make sure to do it in a pencil. So how many even 4-digit numbers are there? So we know that even means just that this has to be 0, 2, 4, 6, or 8, right? And we still know that 4 digits means this can't be a 0, so that doesn't change anything. So we're going to get 5 at the back for here, 1 to 9 for here, so 9, 0 to 10, 0 to 9, which is 10, is what I meant to say. Which is not shocking. We have the exact same amount of even 4-digit numbers as odds, correct? The second bullet is where people go wrong, because with odd numbers, it goes really easy. You only need one case. With even, you actually need 2. And I'll show you why. So, it's not just as easy as the odd where you box and hold. So if I go 0, 2, 4, 6, 8, don't do this, because actually you probably did do this. So I'm just going to show you what to do. So if I leave that back there, correct? Watch what happens. Okay, I have 5. But if I box the 0, let's say, just the 0, I have 1 to 9 here. So I still have 9, correct? Box the 9, I have 1 to 8. What doesn't come back? 0, because I boxed it already. I used it up, right? So if I use the 0, then this would be 8, wouldn't it? If, instead, I didn't box the 0, this is why this doesn't work the way I'm doing it right now. Say I boxed the 2. I would still have 5 options, right? But now I have only 8 for here. I'd have 1 and then 3 to 9, right? Then I can bring my 0 back, box 1, 3 to 9, I'd still have 8, correct? So actually your first number is 8 if you pick 2, 4, 6, or 8, right? But if you pick 0 for your back number, your first digit, you have 9 options, right? So how can we encompass those in one full case? We can't. We can't. We have to encompass it in 2 cases. We have to do 2 cases where, and this is only with evens because of that 0. Our first case is where the back digit is a 0, because that gives us a totally different first number, right? Or we do it where a back digit is 2, 4, 6, 8. We can put those ones together because they all result in the same first number, right? So we can do one case with 0 because it gives us a totally different first digit amount of options. Then we can do 2, 4, 6, and 8 together because they give us a totally different number. Does that make sense? So, I'm going to do the 0. I hold the 0. Then I have 1 to 9. So this is actually only one option, isn't it? And then I have 1 to 9, which is 9 options. I hold the 9. Then I have 1 to 8, which is 8 options. I hold the 8. 1 to 7, 7 options. Or I do this one. So I have 4. Hold the 8. I'd have 1 to 7 and 9. So I have 8 options. Hold the 9. 1 to 7. But what do I have to remember to do now? Bring back to 0, because I never did use it, right? It's a totally separate case. Bring back to 0. And I have 8. 1 to 7. 7. And then I add my cases because I had to have this case or I have that case. So when I have cases, I always add them. Okay? I didn't say this before, but if, we have to have you in alphabetical order, but we also have the ability that if you can't see properly or hear properly, you can be moved. Like, you're not stuck here for life if you can't see or hear where you're sitting, okay? So if that is the case, just talk to me and I'll move you. I just have to keep it on the list and where it is. So we're supposed to keep you alphabetical order, but if you can't see or hear, you can be moved. It's not like you have to be stuck there for life. Okay? You just have to tell me if that's the case. So it's going to be 504 plus 1,792, which is 2,296. Okay? Now, we are going to look at the word English. Okay? When we look at words like English, people will ask me, can I repeat letters? When they give you a word, you can repeat letters if it has repeated letters in it, like loop, for example. Loop would have one L, 2 O's, and a P. Then you could repeat the O's because there's 2 of them. But if we look at English, it's whenever they give you a word, it's like they give you the Scrabble tiles to that word. Okay? So they give you a Scrabble tile that's an E, a Scrabble tile that's an N, a G, an L, an I, an S, and an H, and you can't go in to get more Scrabble tiles. Okay? So in this case, do I have any doubling or tripling letters? Nope, I can't. I don't have options for it. I have one of each. How many letters do I have in English? E-N-G-L-I-S-H. I have 7, right? So I have 7 to choose from, that's it. So let's read through this. Consider the number of distinguishable 4-letter arrangements. Do you see how they don't say words? We're not going to pull out our Scrabble book and see if it's a legitimate word and then it can happen. Okay? They say distinguishable 4-letter arrangements. That just means if you look at the word, just like when we lined up the cards the other day, I told you if they were all different models that you could tell the difference between them. This is the same thing. So if you have 4-letter arrangements, for example, if I had loop, that's different than pool. That's different than opal, right? But is this different than opal? Did I switch the O's? Is it distinguishably different? No. So that's what they're saying. They have to be distinguishable 4-letter arrangements. You have to be able to see a difference in them. Not 4-letter words. Okay? So it could really be like, ee, and that would still be okay, even though you'd never find that as a word. All right? So we have the word English, and we're only using 4 of the letters. So we're going to have 4 blanks. And when we write the blanks, how many things can we put in each of those blanks? How many things can we leave behind in a blank? How many letters? 1, right? When we were parking cars, when we put those blanks, all we could do is park 1 car there, right? when we were picking outfits, we could have one pair of shoes, one pair of pants, one shirt, right? So, it says, consider the number of distinguishable four-letter arrangements that can be formed from the word English. When given a word, it's assumed you only have the letters contained in that word, the amount of times they occur in that word, okay? So, determine the number of distinguishable four-letter arrangements that can be formed from the word English if any letter can be in any position. So we have 4 blanks. We're doing a 4-letter word. There's no restrictions, so I can start wherever the heck I want. I'm going to show this long form, but you're probably not going to do this after a while. So in this blank, I could have E-N-G-L-I-S-H. Now, I told you this before, that unless they say you cannot repeat, you assume you can, correct? But with the word English, being it's an E and N and G and L and I and S and an H, they don't have to say that you can't repeat because they just gave you that word. That's it, right? So they're never going to say, here's the word English, you can't repeat any of the letters. They're going to say, here's the word English, you can only use it. Okay? That's all you have. So whenever you're using a word, you're boxing and holding all the time because you only have that amount of letters to use, right? So you can't repeat. So I can pretend to box and hold the H. So for the first blank, I have 7. For the next blank, I would have E-N-G-L-I-S, which would be 6, right? Then I would hold one of the letters there. Then I would have the options of E-N-G-L-I, which is 5. Hold the I. Then E-N-G-L, 4. What's 7 times 6 times 5 times 4? 42 times 20. 840? So the next one is the first letter must be an E. C is the first and last letters must be vowels. So everyone's really good with a vowel. A vowel is A-E-I-O-U. It's never Y. There's no sometimes Y in math, okay? Because we're not forming words where we need to have a Y as a vowel, okay? The other thing that people forget about is consonant, because you don't say it. You say vowels all the time. Consonant. What's a consonant? Not a vowel. It's not a constant, like a number without a variable. It's a consonant. It's not a vowel. So if there's A, E, I, O, and U as vowels, then there's 21 consonants. I'm just putting it there. You don't need it right now, but that's one thing that everyone forgets about. Remember vowels, you forget the word consonant. Okay? So you're going to do B, C, and D. Try those out. The first letter must be E. So we go 1, 2, 3, 4. This one must be E. So I have one option, right? Then I hold the E there, and then so for the next one I have 6 options, right? 5, 4. Which is 120. 30 times 4, yeah. The first and last letters must be vowels. How many vowels are in English? 2, an E and an I, right? So you can start with the first or we can start with the last, it doesn't matter. I like starting left to right, it's just a preference, but you can do how you want. So I have E and an I as an option, right? So I have 2. But then what do? I hold it, so I have E, which is 1. Right? Now how many letters have I set down? 2 out of 7, so how many do I have left? 5, 4. Could you list the letters below and help yourself out? Absolutely. So your answer to this is 40. Here's the trick. The word must contain G. Does it say where the G needs to be? Nope. So I could have one case where the G is at the front, or a case where the G is in the second blank, or a case where the G is in the third blank, or a case where the G is in the fourth blank. So here I would have one option, right? Then I have how many letters left? 6, 5, 4. we're going to have 1, and then 6, 5, 4. Or 1, then 6, 5, 4. Or 1, 6, 5, 4. So each of these is worth 120. So we could go 120 plus 120 plus 120 plus 120 because the ORs. Or we could just do 120 times 4, which is 480. Your homework is to do the questions to try. So if you look here, it's 1, 2, 3. So you do all those. Go to the next page. 4, 5, 6, 7. Go to the next page. 8, and then here's the answer so you can check it. Okay? So your homework for today is 1 to 8. We don't have textbooks till next week. So you do those questions.